Good morning, everyone, and welcome to the Federation's 125th annual meeting in our new virtual format. My name is Trevor Davison, and I'm one of the environmental farm coordinators here at the Federation. There are a few points I want to go over before we get started. You have joined us today in a Zoom webinar, so we can't hear or see you, and you can't turn on your video. If you have any questions, we ask that you use the chat feature or Q&A on your device. There are bubbles on the bottom of the screen. Hover your mouse or tap your screen if you don't see anything below your video. If you wish to speak using your mic, you cannot unmute yourself. You can raise your hand and we can unmute you. Catherine and Carolyn are monitoring the chat to make sure we get all of your questions and comments. In true meeting fashion, we have a door prize available today. Everyone that was signed into the meeting at the start has been entered into a draw for a Nova Scotia Farm Loan Board prize pack that will be sent out to you. The draw will be announced after Dr. Burton's presentation. We do have a short evaluation for everyone on the webinar here today. It will pop up on the screen at the end. With that bit of housekeeping out of the way, we are pleased to be presenting the soil health webinar today. But I also want to take this opportunity to promote the new agro-environmental program that the EFP is now a part of. For those of you in our audience that may not have heard of this program yet, I want to take a couple of minutes for a brief overview, and my program colleagues, Corey Roberts and Thomas Harrington, will provide some additional information as well. Over the last year, a new agro-environmental program has been developed to promote a more comprehensive approach to environmental stewardship. The program builds on the success of the last 20 years of the Environmental Farm Plan program. It is a new three-way partnership building on the strengths and expertise of the Nova Scotia Department of Agriculture, the Nova Scotia Federation of Agriculture, and Perennia Food and Agriculture Incorporated. This new enhanced program has four fundamental pillars: the Environmental Farm Plan, market access, research and forward thinking, and resources and information sharing. This new initiative will also focus on monitoring and evaluation to help demonstrate risk reduction and increasing environmental benefits on the farm. The agro-environmental program is funded through the Canadian Agricultural Partnership, a federal, territorial, provincial framework. Our vision is for Nova Scotia to be recognized as a national and international leader in agro-environmental sustainability. This new agro-environmental program has been designed to deliver a comprehensive, relevant program to reduce environmental risks on farm through continued participation in the EFP program and new opportunities for applied research on farm, to increase public trust for our industry, and to expand market access to our Nova Scotia farms. Together, the Federation will work with Perennia and NSDA to strive for this mission. And now, I'd like to introduce my EFP colleague, Corey Roberts, to provide an update on recent changes to the EFP program.
Thank you, Trevor. Hello, my name is Corey Roberts, and along with Trevor, I am one of the Environmental Farm Plan coordinators here with the Federation. I want to take some time to share with you some of the changes that have been underway with the EFP program as it has evolved towards EFP 2.0. We will be providing the same high level of service that we have in the past with one-on-one farm visits. The farm visits and conversations won't change, but the reports that farmers receive will change a little bit. Our new detailed reports will contain more farm-specific information to address environmental issues or future activities with links to more general information. The EFP reports will still contain Appendix A's and B's documentation for program funding applications. And as a companion to our new report, we have finalized a brand new environmental guide for Nova Scotia farms, which contains a wealth of information to address general environmental concerns. The guide was created in consultation with the Nova Scotia Department of Agriculture, Nova Scotia Environment, and Perennia. We intend to update the guide annually over the winter and publish a new version on our website each spring. We hope the guide will be the trusted source for environmental information for the industry. There will be a link to the guide on our newly designed website, along with many other information resources, including fact sheets, etc. We are also changing the way we are collecting and handling farm data. We have reviewed our EFP checklist and made several changes. We'll be asking many of the same questions with some additional questions to better capture the environmental status of farms and to integrate with other sustainability initiatives and to help us make better recommendations. We are also developing a geographic information system so we can offer better geospatial information in our reports. We will be doing on-farm data entry, which will go directly into our new database and allow for enhanced report automation. The new system will help us generate high-level key performance indicators that will allow NSDA to measure the success of our program and to help identify trends that can support policy and program initiatives. Overall, the EFP program will continue to provide the same high level of support to the industry with several key enhancements that will increase the value and efficiency of the program over time. With that, I'd like to introduce Perennia's Agri-Environmental Specialist, Thomas Harrington, to discuss some of the initiatives that he is currently working on. Thomas?
Good morning, everyone, and thank you, Corey and Trevor, for the introduction. My name is Thomas Harrington, and I am the new Agri-Environmental Specialist with Perennia. I began with the company in August of this year and will be assisting in the development of the new Agri-Environmental program for Nova Scotia farmers. As a partner in this program, Perennia is responsible for addressing the research and forward thinking and resources and information sharing pillars. These pillars will complement the Environmental Farm Plan and market access components, and will be done by working closely with the Nova Scotia Federation of Agriculture and Nova Scotia Department of Agriculture staff. To support this program over the next few years, Perennia will be focusing on two main areas. One will be resource development and training opportunities to support the mitigation of environmental risks on farm. This will be accomplished by providing workshops and demos, creating new fact sheets, providing webinars, and the creation of a new website with an AEP program landing page. Second, we'll be completing an assessment of where we are as a province in terms of environmental risk by identifying the key elements that need to be addressed. This will be accomplished through environmental risk indicator development, conducting some applied research projects, and also some best management practices scans to other jurisdictions. This webinar falls under the information sharing component and will be the first in a series of webinars. We are planning to do one per month on relevant agri-environmental issues, and we have a few topics in mind and speakers, but we're also open to any suggestions or comments. We will now take a moment to introduce Perennia Food and Agriculture Incorporated as a sponsor of this session.
My name is Jonathan Wirt. I'm the manager of livestock and field crops at Perennia. We're glad to welcome you to today's Ag Environmental webinar, Soils. For the past year, our Perennia Ag Services team has had many changes, including the management team of myself and Jennifer. With Sunny taking over the berry specialist role, we're pleased to have Caitlin Conley in the field crops position. We also welcome Shane Wood as forest specialist and research coordinator, and Katie Trottier as ruminant livestock specialist. Andrew Byers as the ATTA program lead, and Thomas Harrington as our Ag Environmental Specialist, who is on the panel of today's webinar.
My name is Jen Haverstock, and I'm the manager of horticulture at Perennia. Our team has grown significantly with new faces, including QU, wild blueberry specialist, Leah Plaskett, our protected crop specialist, and Jonathan Bent, our research associate. Most recently, we also had an internal change with Sunny Murray now taking on the role of berry specialist. This is Perennia's largest and most comprehensive agricultural services team to date. Now, more than ever, our team is ready to work with you and help support the industry. We are pleased to be a sponsor of today's session and hope you enjoy the presentation.
For our first webinar, we decided to choose the topic of soil health, as it is important for all farms, regardless of commodity, and a healthy soil, it is an essential component of a healthy environment. This webinar hopes to highlight the importance of finding and maintaining balance in soil properties, as each plays an important role for crop production. We'd like to introduce our presenter today, who will be speaking to this important topic. Dr. David Burton is a soil scientist and professor in the Department of Plant, Food, and Environmental Sciences in the Faculty of Agriculture at Dalhousie University. Dr. Burton's research examines the role of the soil environment in influencing the nature and extent of microbial metabolism in soil. His focus has been on processes in the cycling of nitrogen in soils and their implications for soil fertility and environmental impact. His current research programs involve an examination of the production and consumption of greenhouse gases in natural and agricultural landscapes, the development of tools for measurement of soil nitrogen supplied to plants, influence of climate on soil biological processes, and the assessment of the quality of the soil biological environment and its influence on soil health. Over the past decade, his work has focused on potato production in Atlantic Canada. It is the aim of this work to better understand the factors that control soil microbial processes and to use this information to develop sustainable land management systems in a changing climate. He was awarded a Dalhousie University Research Professorship in recognition of his research accomplishments. Dr. Burton is a fellow of the Canadian Society of Soil Science, serves as an associate editor of the Canadian Journal of Soil Science, and is part of the Fertilizer Canada's 4R advisory panel. He has served as chair of a number of national advisory panels with respect to nutrient management and agricultural responses to climate change. He is currently a member of Ecritere's Advisory Committee on Improving Climate Resilience and Climate Mitigation in Agriculture. I am pleased today to welcome Dr. Burton.
Thank you very much. It's indeed a pleasure to be here today. It's a shame I can't be there in person, but I guess none of us can be there in person. So this is what we have to work with. So this is what we will work with. I'm really happy that I have a chance to talk to you about soil health, because I think it's a very topical and important subject that increasingly is coming to the attention of not only producers but policymakers, researchers, and I think it's a very opportune time. Let me see if I can share my screen here. Okay. Oh, wait, now, hold on. I'm sharing the correct screen. Okay, are you seeing my slide screen or my full screen?
We see your full screen.
Okay, good.
Thank you.
So I've chosen the title today of Soil Health or Climate Change Solution, in part because I want to talk about managing soil and soil health and what we mean by soil health. But I don't want us to forget that soil health is not only about production, it's also about our environment, and in particular, one of the big issues that we're facing today, climate change. And soil health allows agriculture to be a very important part of our climate change solution. And I think it's important that we not forget that. So in 2015, it was the International Year of Soils, and the Food and Agricultural Organization of the United Nations did a study of the state of soil, the state of soils globally, and documented the state of soil degradation. And one of the rather alarming conclusions that came based on the global state of soil was that if we don't change the way we manage soil, if we don't manage the rate at which we are allowing soils to degrade, we only have 60 harvests left before we are going to be challenged to feed our population. And that's a rather alarming trend, alarming statement, but I think it draws our attention to the fact that all is not well in terms of how we're managing our soils. And it's also part of the reason why soil health has become an area of focus. We're becoming more aware of some of the challenges that we face in terms of managing our soils. I'm going to focus on two major issues that I think have caused us, particularly in Atlantic Canada, to have challenged the state of our soils. And they're not obvious ones. They're ones that we normally think of as particularly good things, but I'm going to try to make the argument that it's all about balance. The first one I want to focus on is the plow. Plowing soil revolutionized agriculture. It was a way in which we could create a uniform seed bed. We could control weeds. It resulted in the release of nutrients, and when those soils were newly broken, it made them extremely fertile. It allowed us to establish the kind of monocrop agriculture that we've used to feed the world. And so it was a really tremendous advance in our ability to produce food on a large scale to feed an ever-growing population. The challenge is that with any stock, the challenge is that the plowing the soil causes the release, the degradation of soil organic matter and the release of nutrients. But as with any stock, we can deplete that stock. And I think we're now at a situation where the plow is causing significant amounts of degradation of soil organic matter, the decline in soil organic matter levels, and particularly in Atlantic Canada and in Nova Scotia, we're starting to see that the organic matter levels are getting to the point that they're starting to compromise the other functions that organic matter plays in soil. The structural functions in terms of soil erosion and maintaining a good physical structure and aeration, the ability of that soil to hold water and things like that. And so we're starting to question whether or not the plow is necessarily always the right tool. The other important innovation that has revolutionized agriculture is fertilization. 150 years ago, Justus von Liebig discovered that we could grow plants in the absence of anything other than minerals. All we needed to provide was mineral nutrition and plants would prosper. 100 years ago, Fritz Haber and Karl Bosch discovered a way in which we could take the 78% of nitrogen that is contained in the atmosphere and transform that into a form that could become available to plants. This was the basis for nitrogen fertilizer. And together, those discoveries allowed us to realize the green revolution. We in the 50s and 60s, we dramatically altered the amount of food we could produce per acre, and that allowed our population to grow significantly. In fact, to the point where about half the nitrogen that our population consumes comes from this Haber-Bosch process. But again, we can have too much of a good thing. One of the adverse impacts of all that nitrogen fertilizer used is that we've actually doubled the amount of reactive nitrogen that exists on this planet. And that reactive nitrogen can feed plants, but it also can impact the environment. And so now we're having to deal with the challenges that reactive nitrogen has caused in terms of contamination of our groundwater, in terms of nitrate in our surface waters, in terms of estuaries, but also impacts upon our atmosphere as ammonia loss or as nitrous oxide, a greenhouse gas, one of the subjects that I study. And so these two processes, cultivating the soil, fertilizing the soil, are concepts that are near and dear to our hearts in terms of our husbandry of soil and our production of crops. And I guess what I'm trying to, I think, reflect to you is that we have to have a little bit more balanced view of them. It's all about how we use these tools and how we assess their impact on the environment and ensure that we're using them in a productive and beneficial way, and not allowing them to contribute to soil degradation. This realization, this for a balance, was one of the major things that gave rise to the concept of soil health. About 20 or 30 years ago, people were talking about soil quality. It's a term that didn't really connect with people, but soil health is a much more evocative term, a term that we can more personally relate to as it relates to our own health. But fundamentally, one of the really revolutionary aspects of the concept of soil health is traditionally when we've tested soil, we've evaluated soil, we've simply measured its nutrient state, its chemical status. And we've used that measure of chemical status to inform our management. Soil health is a much broader concept of the state of soil. It embodies both the physical state of soil, the chemical state of soil that we've traditionally measured, but also the biological state of soil. And together, that physical, chemical, and biological tries to assess more holistically how soils function. And in many regards, that's something we've inherently understood. We understand that the problem we may have soil may not simply be nutrition. Sometimes it's physical structure or compaction. Sometimes it's a low organic matter or a lack of water holding capacity. So we've understood these various elements of the soil state, it's the soil's function, but we really haven't had effective ways of measuring that. And that's where soil health comes in. It tries to actually allow us to measure the state of the health of our soils in a way that it can inform our management. This gave rise to an initiative at Dalhousie University. In 2016, we received funding from Agriculture and Agri-Food Canada through the Agricultural Greenhouse Gases Program to establish the Atlantic Soil Health Lab. The objective of this lab was in part to bring some of the methods that were being developed in the US, particularly at Cornell University, to Nova Scotia to establish a lab that would allow us to conduct a survey of the state of soil health in Nova Scotia, in Prince Edward Island, and New Brunswick primarily, and use this information to determine whether we can actually document and recommend beneficial management practices that could address some of the soil health issues that we were identifying. So we started to do a sampling of various production systems in Nova Scotia and PEI primarily, but also more recently New Brunswick. And we've sampled a number of different sites. This has been in collaboration with Perennia. Perennia has been a tremendous asset in interacting and identifying producers and helping us with the sampling of these sites. Our intent has always been to try to capture both the diversity of soil types within Nova Scotia, but also the diversity of cropping systems. One of the real strengths of agriculture in Nova Scotia is we still have quite a diversity of production systems, from wild blueberry, pastures, hay fields, but also intensive production and vegetable production systems, berries, grapes, these kinds of production systems. So we wanted to really assess whether this soil health tool could help us to try to understand which of these production systems were challenged in different sorts of ways in terms of the function of the soils that were supporting those production systems. Here's a high-level analysis of all the different variables we measured in this soil health analysis. So that's the other difference between the soil health analysis and the more traditional chemical assessment is there's a much wider range of variables that we measure. And this I won't try to explain all these variables because they're many and complex, but they try to assess the physical, chemical, and biological state of soil. And here in this graph, we've tried to represent the degree of variability in each of the variables that was explained by cropping system, the black bars, or by soil type, the open bars. And one of the really important observations we made, and it wasn't a surprise to us, but it was an important observation, is that cropping system, how we manage our soils, is having a far more profound effect on the state of our soils than was their pedogenic origin, whether it's a podzol or a luvasol or the soil type per se. So management has dramatic impacts upon the state of soil, its soil health. But that also tells us we have tremendous opportunity to influence the state of the health of our soils through our management choices. So we talked about the plow. One of the things that we're realizing in Eastern Canada as a whole is this decline in soil organic matter is a problem throughout our intensive cropping systems of Eastern Canada. So the annual cropping system, corn, soybean, wheat, intensive production systems, the degree of soil disturbance is such that organic matter levels have been in decline for decades. And now they're getting to the point where the level of soil organic matter is starting to threaten the function of those soils. In Western Canada, this also was the case 30 or 40 years ago, but one of the things they've done in Western Canada is more broadly adopted the concept of reduced tillage. And through reduced tillage, they've been able to rebuild some of the organic carbon content such that, as you can see in this graph, that part of Canada is green. Why is it green? Because soil organic carbon levels are increasing because of the adoption of reduced tillage practices. Okay? And so that's one of the things we wanted to try to look at. So as part of our survey of some of the cropping systems in Nova Scotia that we did in collaboration with Perennia, we tried to identify some systems where They were using some practices we think might be able to build soil organic matter. So in this case, we're looking at systems that were amending the soils with organic carbon, either through manure or compost or some other organic source, and soils where there was a relatively low degree or high degree of disturbance. So how much disturbance was the soil getting through the crop rotation? And here we've compared that in terms of this graph. So, so you'll see here we have systems that were amended with organic matter but had high disturbance, systems that were amended with organic matter but had low disturbance, and we're comparing them to systems that did not receive organic matter and were under high disturbance, and systems that were not receiving organic matter but were under low disturbance. Our initial thought was, well, of course, when you're adding organic matter, you're going to build soil organic matter levels. That's an obvious beneficial management practice. But one of the things that really surprised us was the importance of disturbance, of low disturbance, in terms of building soil organic matter. You'll see here, even in our non-amended situation where we're not adding organic matter, by having low disturbance agricultural systems, we have the opportunity to build soil organic matter or have higher soil organic matter levels. A lot of variability, suggesting we need to understand why these systems are not accumulating organic matter, but these are. But one of the things we really want to note here is that it's in sharp contrast to the situation where we're not adding any organic matter and we're resulting in high disturbance. In those systems, it's quite uniform, the results, and most of that uniform results are low organic matter contents. So it really emphasizes both the role both of amendment, but also reducing soil disturbance in terms of trying to build soil organic matter. We also see that in terms of another measure of the health of soil, aggregate stability. So this is the same comparison. Instead of looking at the total carbon content of the soil, we're looking at the wet aggregate stability. So that's the ability of the aggregates that are present in the soil to resist the impact of raindrops. And we see, as we saw with the organic carbon content, the non-amended high disturbance system had the lowest aggregate stability, something in the order of 20 to 30% of the aggregates were water stable. Whereas in these systems that were either receiving or that were under low disturbance, all had had the capacity at least to have much higher percentage of aggregates that would be water stable. And also, again, even in the high disturbance system, the amendment of carbon does show the potential to mitigate some of the effects of that disturbance in terms of water stable aggregates. And why are water stable aggregates important? Well, those are the structures that resist soil erosion, but those are also the structures that allow soils to store more water. And as we move into a climate where periodic drought stress becomes more frequent, the capacity of soils to store water is a really important aspect of their ability to sustain crop production year in and year out, dry years and wet years. And so it's a really important physical aspect of the soil to be mindful of. And here we're just showing a little bit of a distribution of this wet aggregate stability measure as a result through various cropping systems that we measured within Nova Scotia. The vegetable production systems, which had much higher disturbance, had much lower percent water stable aggregates compared to lower disturbance systems like pastures and wild blueberry. And then some of the forage production systems were more intermediate, with some higher, some lower, and same with field crop. Well, tended to be somewhat lower, but there also were examples of systems where there were maintaining high wet aggregate stability. And so again, I think this focuses on the opportunity for management to help us to improve the health, improve the physical structure of the soil. We also highlighted the issue of fertilization, and I pointed out the fact that this ability to synthesize ammonia was a great opportunity in terms of our ability to produce food, but also has the potential for high environmental impact. And again, we're seeing this is another one of Agriculture and Agri-Food Canada's agri-environmental indicators. In this case, it's residual soil nitrogen, and that's the amount of soil that's remaining in the soil after the harvest. And again, you'll see Eastern Canada is much redder than Western Canada, suggesting we're leaving a lot of nitrogen in the field after the harvest. And this is the nitrogen that, particularly in Atlantic Canada, can be lost to the environment. most of our nitrogen losses occur from harvest to seeding over the winter period, either as leaching to groundwater or nitrous oxide emissions to the atmosphere. And therefore, it's very important that we focus on not leaving too much nitrogen in the field after harvest. Here's a graph that actually compares the net N additions versus the net N removals for Canadian agriculture over the past 50 years, 50, 70 years. And you'll see that we started out with a point where N removal in cropping systems was greater than N addition. We were actually mining the soil and we had negative residual nitrogen. But we've moved to the point where now what we're adding is in excess of what we're removing, and we're actually getting a positive residual nitrogen year after year. So nitrogen is accumulating in our soils. There's a higher potential for loss. This is also reflected in another of the agri-environmental indicators, that is the risk of water contamination by nitrogen. And here we're focusing in on Atlantic Canada, the Maritimes, and we're seeing that we're getting lots of orange and red areas where we have higher risk of nitrogen impacts upon water. So what are we going to do about that? Over the last decade or so, we've been working on a system that will allow us to measure the state of nitrogen in the soil and use that as a way of trying to decide how much nitrogen we should apply. Those of you that have been doing routine soil tests over the years know that when you send a soil test in, you hear about the phosphorus, the potassium, the calcium, the magnesium status of your soil, the pH status, the buffering capacity, base saturation, but we don't report on the nitrogen state of the soil. And that's because the nitrogen tests that are used in other parts of the world don't work very well under our climatic conditions. So we've been working at Dalhousie and in collaboration with Agriculture and Agri-Food Canada to try to develop a nitrogen test that will work for Atlantic Canada, and we think we have one. And so what this is part of a system where we actually implement this soil nitrogen supply test to measure the potential of our soils to mineralize nitrogen. The soils produce a significant amount of nitrogen. We want to be able to measure that so it can be reliably considered as part of an input into your fertility recommendation system. We contextualize that measure of N supply capacity for the climatic conditions that we experience within your local region to actually estimate the plant nitrogen availability in that system. That can then be used as part of a 4R nitrogen management program to decide what the right place, product, timing, and source of nitrogen that should supplement the soil's mineral nitrogen supply, and then we grow the crop. Here we have some tools we also use on a research basis to try to evaluate the potential for nitrogen loss during the growing season. And we also can measure this residual nitrogen that remains in the soil in the fall to see how much is left over, and whether we can use some post-harvest tools to try to immobilize or stabilize that nitrogen so it be carried over to the next year. And that's again part of this whole soil health process is trying to ensure more continuous crop cover. One of the challenges with the annual cropping system is after harvest, the soil sits bare for an extended period of time. And in Atlantic Canada, that's the period of time when nitrogen losses are most likely. And so we want to try to look at management practices that can reduce that. One of the management practices we've been looking at, again in collaboration with Perennia, is cover cropping. And here's some data we've been looking at where we're reporting this biological nitrogen availability. So this is the capacity of the soil to supply nitrogen. How is that influenced by cropping systems where a cover crop is being routinely implemented as part of the rotational system, comparing that to one where a cover crop is not included? And what we see is we can dramatically increase, or at least there is the potential to dramatically increase, the amount of nitrogen that's being retained in that system and is potentially available to the next year's crop. And that's an important consideration, both in terms of minimizing the potential for overwinter loss, but also that increases the amount of nitrogen that's being supplied to the next year's crop, and so reduces our need for nitrogen fertilizers. And that has very important agronomic and economic implications. We also surveyed the potential nitrogen mineralization over a growing season. So we estimated how much nitrogen could be mineralized from these soils over 130 days. And you'll see in some cases, these numbers are very large, hundreds of kilograms of nitrogen per hectare. This is an amount we're not routinely considering as part of our nutrient management planning process. We're not factoring in the fact that for some cropping systems, there's a lot of nitrogen being supplied by the soil. We're ignoring that. Whereas in other cropping systems, we're having, whoops, what happened? Other cropping systems, we have much less, and perhaps we should be adding more than we're currently adding. But by measuring this extreme variability in the nitrogen supply, inherent nitrogen supplying capacity of these soils, and using that as a part of our nitrogen recommendation system, we should become able to become much more efficient at our nitrogen use, our nitrogen fertilizer use, becoming more economically efficient, but also becoming more environmentally efficient, reducing our environmental impact. And so part of our goal at the Atlantic Soil Health Lab is to try to develop and implement a soil testing process that will allow us to measure the nitrogen supplying capacity of our soil to better inform the amount of nitrogen fertilizer we should be adding to these systems and the potential for environmental impact. I said that one of my topics, or one of the subtitle of my topic, was our soil health, our climate change solution, and I want to just take the last few minutes of my talk to focus on that. You've seen this map before. This looks very similar to our organic carbon map, our residual soil nitrogen map. In this case, it's our greenhouse gas emissions from agriculture. Again, Eastern Canada is red, Western Canada is green. And that's in part because of high degree of disturbance in the production systems, causing CO2 releases organic matter. It's also partly due to the rates of nitrogen fertilizer application causing nitrous oxide emissions. So what can we do about that? Well, soil organic matter is 50% carbon. It presents a tremendous opportunity to take CO2 out of the atmosphere and store it in soil. So while I want you to build your soil organic matter to enhance the function of the soil, its fertility, its water holding capacity, its ability to resist erosion, we're also taking CO2 out of the atmosphere and helping our climate change, our attempts to combat climate change. Increasing soil organic matter by 0.1% represents the capture of 15 tons of CO2 from the atmosphere. That's a lot. So we have an opportunity by reducing our degree of soil disturbance, by using these organic amendments to build the carbon content of our soil. We also have the opportunity to reduce our N2O emissions by more judicious and more strategic use of nitrogen fertilizer. In Nova Scotia, our net greenhouse gas emissions, the areas where we're having high greenhouse gas emissions are also those areas where we have more intensive nitrogen fertilizer use. And so one of the things we can do is we can realize reduced N2O emissions by as much as 30% by a whole series of practices which are being promoted by the industry, and they're being referred to as 4R nitrogen management. Using the right source of nitrogen, putting it on at the right time, at the right rate, and that's very important, and in the right place. And so by using things like enhanced efficiency fertilizers, like fertilizers that have been treated with inhibitors or coated with various products, using split applications of nitrogen, so we're timing the nitrogen so it's available just when the plant needs it and it's not sitting there all through a wet spring period where it could be lost. Greater reliance of manure and legumes to not only contribute organic carbon to the system, but also take advantage of those nitrogen sources, and also reducing our rates of nitrogen fertilizer. So we're only using just the amount we need. We're accounting for the soil nitrogen mineralization. These present a tremendous opportunity to reduce our reliance on nitrogen fertilizer, not only improving the bottom line, but also importantly, reducing the potential for nitrous oxide emissions, nitrous oxide production, a very potent greenhouse gas. So that's basically what I wanted to say today. I wanted to highlight the fact that this concept of soil health is a much broader concept of the physical, chemical, and biological state of soil. Improving soil health does multiple things for us in terms of not only increasing the fertility of our soil, but the decreased potential for erosion, the ability of our soils to hold water and resist drought, and also decreasing the greenhouse gas emissions from that system, sequestering carbon, reducing N2O emissions. One of the things I haven't talked so much about is we need to develop the capacity to measure soil health in Atlantic Canada. The Prince Edward Islands Analytical Services Division is actually piloting a soil health test for commercial application in Atlantic Canada, and I think that's a discussion we need to have in Nova Scotia as well. But also I want to highlight the fact that there are some beneficial management practices that we can adopt that can help us to improve soil health. That's reducing our degree of soil disturbance, avoiding recreational tillage. Till when we have to till, but try to avoid tillage whenever possible. Increasing the plant cover of our soils, using cover crops, keeping something growing in the soil as much and as long as possible. More diverse cropping systems, the increased use of legumes, reincorporating legumes back in our pasture systems and in some of our cropping systems to not only fix nitrogen, but also provide more organic matter, and increased use of organic matter inputs. They're critical to sustaining our organic matter content of our soils and maintaining their soil health and those other factors that soil health provides in terms of soil function. So with that, I'll end, but I also want to highlight the fact that this research has been supported by a whole diverse group of people, from funding agencies through producer groups and industry. And I think it's that synergy between research and the industry that has made this a successful program. So with that, I'd be happy to take any questions if there are any.
Okay, thank you. We have at least one question in the chat room here. Oh, there it is. I'll read the question out. I appreciate your presentation, and I know this information to be known for decades. How is the societal container, capitalism, imperialism, etc., being addressed so that farmers can grow without pressure to adopt soil degrading practices, as well as transitioning to practices to prepare for climate chaos? And that's a big question with lots of elements to it. I don't know if you can address some of those, Dave.
Well, soil health actually is a concept that actually is supporting, is very consistent with the concept of grow local, smallholder type approaches to agriculture. And we often characterize the very intensive agricultural production system as industrial agriculture, very interdependent, very commodity driven. The move to soil health is being embraced by people that are production systems that are much more resource aware, if you will, and are much more aware of some of the opportunities that local purchasing provides, and also ways in which we can reflect the value of sustaining a resource in the value of the product we purchase. So I think part of the challenge is when we buy food, we have to be thinking more than just the kilogram of carrots we're buying. We have to be thinking about what's the production system that carrot has been produced in, and what's its relationship to the environment and the society that is supporting that. And so I think some of these issues are really relevant ones. They are very difficult issues to represent in a global agricultural trading system, a commodity trading system. And so there is still a challenge as to how do we value sustaining the quality of a resource and the environmental goods and services that sustained resource provides in a way that it can be reflected in a system where we're doing global trading of food.
Okay, very good, thank you. couple more questions here in the chat room. Excuse me. We have a question related to the Reams soil test. Any chance of having access to the Reams soil test? I must admit, I'm not too familiar with the Reams soil test, but do you have a comment on that?
I apologize. I'm not either. I don't know what the Reams soil test is. So maybe perhaps we can get some clarification on that.
Okay. All right. Moving on to the next question. As a scientist, do you find that politicians listen to your research? I ask as a farmer, researcher who has been studying agroforestry with people for 30 plus years. How is your relationship with policymakers?
That's one of the other really valuable things about the concept of soil health, the term soil health. It resonates not only with producers, but the general public, but also politicians, interestingly. So I've been 30 years, I've been trying to push the concept of greater investment in environmental issues in agriculture at both federal and provincial levels. I think we have their attention now more than ever. The climate crisis is part of that, but also a growing awareness of the importance of food security, sustaining our food production system. I think they're listening. Maybe I'm just being the optimist, but I think they're listening. So I think this is the right time. I think this is the time when we can get the support of the political, the powers that be, federally, provincially, and so I'm very optimistic. I think I'm excited as to what's going to happen in the next 5-10 years.
Question?
We're going to ask Joe to clarify.
Okay, yep, so we're asking for clarification on the Reams soil test question. Do we want to?
Joe was there for a minute.
He disappeared.
Okay, another question from Jeanette McDonald. With reduced tillage practices, we see the use of more selective pesticides. How can we share to the public what this means for soil health? Can we reduce tillage and reduce pesticide use?
I'm, as with nitrogen fertilizer, I believe a pesticide or herbicide in particular is a very important tool in agriculture. And I think that the job we have is to portray to the public that we're using them as judiciously as possible. And so I think it is a tool that allows us to reduce tillage, provide weed control other than through soil disturbance. And so I think it's an important tool. I do think we're actually understanding the ecology of plant production such that we understand different ways we can control weeds other than the use of herbicides. And so plant competitions and understanding diverse and multi-species plant stands is becoming much better. So we actually should be able to even further reduce our reliance on pesticides. But I'm not a believer that an absolute removal of pesticides from the production system is a necessary thing. I think it's more about judicious and careful use and ensuring that we can document the safe use of those tools.
Very good. There's a couple more questions here. So Danny's going to say his question. Okay. And that's Danny Davidson?
Danny Bruce.
Oh, Danny Bruce. Okay. Danny Bruce, if you're able to unmute yourself, then you can ask your question directly to Dr. Burton.
Is that it?
Yep, we're hearing you.
Okay. So I'd like to, I'm sorry about the technical things here. The The Reams test, I would like to comment a bit about it. The Reams test is the testing of the soil for, to my understanding, for available nutrients, not so ones that are available presently to the plant, rather than ones that are chemically in the soil. So that's one of the areas that I've been interested in, because just because the soil has calcium, for example, it may not be available to the plant. So I would be interested in measuring the soil for available nutrients. That's the comment I'd like to make. Thank you.
Dr. Burton?
I'm assuming by available to the plant, you mean they use some sort of a bioassay or plant assay, because our traditional soil testing methods have used various extractants that try to emulate the availability of the nutrient to the plant. So for example, in Atlantic Canada, we use a MELIC3 extraction. It doesn't extract total nutrients, it extracts a proxy of plant available nutrients. So I'm assuming that this Reams test has a different extractant or a different process by which it differentiates between plant available versus total nutrients. And unfortunately, I can't comment on the test because I don't know what mechanisms or what extractants they're using.
Can't believe it.
Okay, thank you. Another question from Bill Jung. Do you have a real-time data for soil collection?
And that would be lovely. We actually have a new faculty member who's a digital soil mapper, Brandon Hung, and my hope is that Brandon will be able to better able to deal with a big data acquisition and delivery approach. But right now, our soil health analysis is a research effort, and therefore it's not at all real time. It's taking us quite a bit of time to collect and analyze and understand this data and distribute it back to producers. We weren't helped by the fact we had a bit of a little fire a few years ago that put our lab out of business for about 18 months. But real time that's something that I think in the future we might be able to realize by using a number of the sensing technologies. So, I think Danny's not okay. Agriculture is going through a revolution where we're getting a number of ways in which we can sense the state of soil remotely through satellite data, through various instruments that we can bring across the field. And there's a lot of interest in using those types of tools to measure characteristics of soil like organic matter that could give us a much more real-time sense of the state of soil. And so I think you're seeing a lot of people interested in putting that on equipment and making decisions on the go. And there's a precision agriculture group in our faculty. There's as I said, Brandon's a digital soil mapper. So I'm optimistic in the future that'll happen. We're not there.
Okay, thank you. I think we have a bit of time for some additional questions here. So this one coming from Melvin Farms. Are you familiar with organizations such as Indigo Ag, which remunerate farmers for capturing carbon in their soils?
Yes, a little bit. And I think that's it's an interesting proposition. I think the challenge we're going to have in Atlantic Canada is that the data requirements to document those carbon projects are rather extensive, and the magnitude or the size of our projects are relatively small. So if you're a prairie farmer and you've got 5,000 acres, the costs of the transactional costs of generating a project may be such that you are going to be able to realize a meaningful carbon return or a carbon payment. In Atlantic Canada, an individual farmer is not likely going to have sufficient area, and our potential for loss is sufficiently great that it's going to be much more difficult to make that pay. I do think on a provincial basis, we might be able to aggregate some of these projects, so we could, as a community, as a group, as a federation, realize some of those projects. But right now, the transactional costs are such that they're very hard to make pay.
Okay, thank you for that. We have time for one more question. This one coming from Maxine McLean here at the Federation. She asks, at the Federation, we have a soil health standing policy. Based on conversations with farmers, we know soil health is in part an economic decision. Can you comment on actions that have been undertaken elsewhere at the government or market level to support farms working to improve soil health?
I'm actually working with a number of farmer groups nationally that are trying to find ways in which we can convince the government to invest in some of these soil health types of initiatives. Some of the investments are about infrastructure. Some of it are about incenting actual practices that can encourage producers to adopt soil health practices. Some of those are things like demonstrations, but sometimes they're things like offsetting seeding costs and things like that. So one of the groups I work with is Farmers for Climate Solutions, and they're trying to again lobby the federal government to provide a mechanism by which farmers can adopt these practices, in part because they're new practices, and there needs to be some demonstration opportunities. There needs to be some sharing of risk to allow them to adopt these practices. So it's happening. I think there's a responsiveness within various levels of government to undertaking that. So I think it's encouraging. I think also the other driver in this is the supply chain. I think increasingly the Walmarts, the McDonald's, the purchasers of our products are starting to demand that we are able to document that we're undertaking some of these practices, and that's a bit of a mixed blessing. Sometimes they're willing to demand that we adopt these practices. They're not always willing to pay for us to adopt these practices. So that can be a different kind of a challenge. But I think there is pressure from the supply chain to adopt more or be able to at least document our ability to adopt or our adoption of more sustainable management practices. Can I ask that there's one more question in the chat that I'd like to address if at all possible. That's another one from is regarding the Mi'kmaq stewards and foragers. I've not had the ability to so the question is, what is your relationship with the Mi'kmaq land stewards, foragers, who steward the land very differently than many of us settlers? Unfortunately, I've not had the ability to connect with the Indigenous communities as much as I'd like to. So if there's any of you that are on this call that are involved in that community and would like to connect to talk about soil health and some opportunities, I would love it if you reach out to me, because I do think there is a different perspective that we're not necessarily hearing. And I think soil health is a concept that's very conducive to that perspective. And so I guess that's an invitation on my part, or a request, a plea for anyone who is involved in that community to reach out so we can connect. Okay, I'm understanding we've got time for one quick last question here, and there's one left in the chat room. So if you'll indulge one more question. How do fertilizer companies contribute to your research directly? Oh yeah, they do. I guess that's disclosure on my part. I have received funding from Fertilizer Canada. So Fertilizer Canada is it's a group that represents fertilizer dealers. And so they have funded a lot of my research in Prince Edward Island, looking at ways in which we can reduce nitrogen fertilizer use in potato production. So I acknowledge that that I do have that industrial support. I do maintain that they have no relationship to my research objectives. They don't set my objectives. They don't design my experiments for me. And also, the major goal of my research is to reduce nitrogen fertilizer use. So so I don't think there's a conflict of interest there, in that my major focus is to use nitrogen more efficiently. I think as an industry, they're starting to get it that the fertilizer industry in the future is not going to be about selling more product. It's going to be selling more information so we can use product more wisely. And I'm really encouraged that I think that the industry gets that. And so it's changing its focus as well. So for example, Fertilizer Canada has been a leader in the promotion of 4R, the 4R concept of using nutrients more efficiently, both nitrogen and phosphorus. And I'm really encouraged by that, because quite frankly, we can't view this as an us versus them type of situation. We all have to be pulling in the same direction to try to ensure that we're able to produce our food as sustainably as possible, while minimizing our impact on the environment. And until we all start pulling in that same direction, we're not going to make nearly the progress we need to. But again, I'm encouraged that that's what's happening. We are all pulling in the same direction.
Well, with that, I think that's a good note to end on. So I want to say thank you very much on behalf of the Agri-Environmental Program for spending the time with us and putting together that thought-provoking presentation and answering our questions. Thank you.
Thank you. It's my pleasure. Again, it's a shame I couldn't be in a room with all of you but this is what it is.
Right. And normally we would present our guest speakers with a small token of our appreciation. This year, in lieu of gifts, based on our proximity to one another, we're making donations to the food bank, Feed Nova Scotia, on your behalf.
Thank you very much. I think that's very appropriate.
Well, thanks again.
Thank you.
And one or two additional notes I want to add here. As mentioned up front, there was a door prize that was going to be awarded to one of our participants, and the winner of the door prize is Shaunid McDonnell. So congratulations, Shaunid. We'll be in touch with you in order to get that out to you. And on another note, if you haven't registered for the Farm Transition webinar tomorrow, or the Nova Scotia Young Farmers AGM starting at 7 p.m., it's not too late. You can do that on our website. And finally, I'd like to say thank you to everyone who joined us for the presentation today. Thank you very much.